So this video is going to be based on solving rational inequalities. It's a follow on from the linear inequalities and quadratic inequalities in the same section. So just first of all, just to remind you, a rational number is just another way of writing a fraction. It's another word, it's a fancier word for saying a fraction, because you can write it as a ratio, so 1 out of 2 or 3 out of 4. Also, in the last couple of videos, I've explained it's very important what happens with the inequality signs when you're crossing over the inequality. So you can add or subtract a number to both sides and it doesn't change the inequality, that's no problem. You can multiply or divide both sides, that's no problem. But when you multiply or divide by a negative number, that's when problems happen. So first of all, I'm just going to show what happens again with this. So if I'm trying to just get rid of this fraction, I can cross multiply. The 2 will go up here and the 4 will go that way. So 4 by 1 less than 3 multiplied by 2. 4 is less than 6, which is grand. That's perfect. That's no problem. Now, what happens if I cross multiply by a minus number? Now, if I do the same thing, the minus 2 will go up and multiply by 3, same as I've done on the left. The 4 will come up and multiply by 1. So 4 by 1 is less than 3 multiplied by minus 2. 4 by 1 is 4, that's okay. 3 by minus 2 is actually minus 6. And minus 6 we know from the number line. Minus 6 is definitely not bigger than 4. It should be the other way around. So when I multiplied by a minus number, so the minus 2 came up and across to multiply by 3, this inequality has to change. So that's not right. It should actually be 4 is greater than minus 6. So it flips over. Okay, so that now is going to lead on to directly to what happens with algebraic inequalities. Okay, so in this example, we have 2x plus 1 over x plus 2 is less than a half, and we need to try and solve that and find the solution set for it. So, the main issue that we might have here is the example from what I have above. If you cross multiply by positive, it's grand, nothing happens to inequality. If you cross multiply by a negative, then there will be a bit of a problem. Now, there is an issue with this bottom part down here. Now, just looking at this, because x is a variable, we can't guarantee that this denominator is positive. This 2 is okay, that's no problem. But if this is negative, then we have a problem. If x is 4, grand, 4 plus 2 is 6, so that's no problem. If x is something like minus 10 plus 2 is minus 8. But because we don't know what x is, we can't guarantee that when we cross multiply, nothing will happen. So the only way we can cross multiply by something to guarantee that it's positive would be to multiply both sides by x plus 2 squared, because any number squared is positive. And if I can guarantee that I'm multiplying both sides by a positive, then we know for a fact that the inequality in the middle won't change. So what I'm going to do is just multiply both sides by x squared plus. We know for a fact that this is greater than or equal to 0, so we're okay. So what I'm going to do is just multiply both sides by x plus 2 all squared. Multiplied by 2x plus 1 over x plus 2. And the same on the other side. Now, this does look a little bit more complicated, but it makes it easier because we've 2 x plus 2's up here. There's 1 underneath, so one of those will cancel with all of this, and now our fraction has almost disappeared. So I can multiply out as normal. Actually, I'll write it out easier just to make it easier to see. All over 2. So now if I multiply this out, we get, actually what I'll do first, because I still have a fraction on this side, I'll now bring this 2 over and across and multiply it, because I know for a fact that multiplying by positive 2 won't change the inequality, so nothing will make a difference. So now I've got 2 multiplied by x plus 2 multiplied by 2x plus 1 is greater than or is less than 1 multiplied by x plus 2 all squared. So now you just expand. 2 by x is 2x. 2 by 2 is 4. This will now multiply by 2x plus 1 in a second. Because there's 3 in a row, it just makes it a little more complicated. Less than 1 multiplied by anything. So now I'll just expand this left hand side. We get 2x by 2x is 4x squared. 2x by 1 is 2x. 4 by 2x is 8x. And 4 by 1 is 4. Less than x squared plus 4x plus 4. So now, because the x squared is positive on this side, because the 4x squared is bigger than the 1x squared on this side, I'm going to bring everything to the left hand side to make it a bit easier. So we now have 4x squared plus 2x plus 8x plus 4. This x squared comes over and becomes minus. The same with the 4x. And this 4 also becomes minus. So now everything is back on the left. Clean it up a small bit. 4x squared take away 1x squared is 3x squared. 2x plus 8x is 10x. Take away 4x is minus 6x. Plus 4 and minus 4, they cancel. So now all I'm left with is 3x squared minus x is less than 0. We're nearly done. Because there's a 3 here and a 3 here, I can divide everything by 3 to make it just a little bit easier. So I'll just put a note on this side. Divide both sides by 3, so that will give me x squared minus 2x is less than 0. Now we're back to the similar setup that we had in the last section, but because it's not a full quadratic, so it doesn't have ax squared plus bx plus c, we can actually just factorize this left hand side. So we'll x bracket x minus 2 is less than 0. We now need to look at, right, x is here and x minus 2 is this side, less than 0. When we were working with inequalities in the last video, we just forgot about that inequality for a minute and solved the question as normal. So now, as a direct follow on from the last section here, where we had x multiplied by x minus 2 is less than 0, what we're going to do is ignore this section here, this inequality, and we're going to use it as an equals for a minute. So again, we go to case 1, case 2, x equals 0, or x minus 2 equals 0. So that would mean x equals 2. So now I've got my two roots of this equation. Now, if I go back to what the equation actually looked like when I multiplied it all out, it was this, 3x squared minus 6x. Because 3x squared is positive, that means the graph is going to be a U-shaped graph. It's positive. Now, if I can mark in the roots, I'm nearly done. I'm almost done. So I'll draw a quick quadratic graph. One of the roots is 0, one of the roots is 2, and we know it's positive, so it's going to be a U, so it looks something like this. That's what our graph looks like. Now, to go back to the equation again, 3x squared minus 6x is less than 0. This line here, this is the cleaned up version of the whole equation. So they want to know, when is this graph less than 0? It's less than 0 between here and here because it's under the line. From solving our question above, we know that this point here is x equals 0. We know that this point is x equals 2. And the negative area, or when it's less than 0, is under this curve. So it's between these two. So my final answer is 0 is less than x less than 2. Now we don't put in the equals there because if you go back to the original question, it's not equal there. It's just less than. So this part is just less than. So this is my final answer.